All right, everyone, welcome to Newegg Studios. I'm Josh from Newegg. So today we're talking with JJ from ASUS. Now, if you don't know, JJ is one of the smartest guys in the biz. This guy knows everything there is about PC building, overclocking, almost everything. Mostly everything about ASUS motherboards. Specifically, we're looking at new Z270 motherboards from ASUS, the Apex, which is their top-of-the-line overclocking motherboard. It does a lot of other cool stuff, as well as the STRIX Mini ITX board, which we've got a little build going with NZXT. So we're gonna do some cool demos. We're gonna take your questions. And so if you got some cool questions for JJ about overclocking, Z270, i7, anything cool that's going on, as well as just newbie questions, don't be afraid to ask some sort of beginner intro stuff, as well as expert level stuff. In any case, let's take it over with JJ.
Hi, everybody out there in YouTube. I'm super excited to be here at Newegg Studios, being able to get you guys a little bit more informed on what we're doing for the latest generation of Z270 series motherboards and Intel. But like Josh noted, we definitely want to keep this open and easy for you guys in terms of the different questions you guys can ask, whether it's PC DIY centric, whether it's graphics card, building related, overclocking centric. Really, it's up to you in terms of what you're going to be able to ask, and I'll do my best to go ahead and be able to provide insight and clarification in regards to that. Circling back to what Josh talked about, we've got two really awesome boards that we want to be able to touch on a little bit more, give you guys some insight. One I've got here in this small form factor gaming rig, which is our STRIX Z270i Mini ITX gaming board. It's pretty beefy, pretty nice setup here actually, and with our Kaby Lake overclock setup that we're going to hopefully be able to walk you guys through. We'll give you some insights into automated overclocking, manual overclocking, and how even in a system this small and with a board that traditionally you wouldn't necessarily think about higher end overclocking, we can even get to numbers like 4.8, 4.9, or even 5 gigahertz. That's really one of the unique things and really impressive attributes about Kaby Lake in terms of the 7th generation series processors, where we're seeing quite a bit more aggressive CPU frequencies. And definitely touching on that, we've got another really special board here, which is the brand new Apex board. So we showed this off along with the Mini ITX board at CES, and I know for a lot of you, you've been really interested in finding out a little bit more about what makes this board special. So while we've definitely been touting some extremely world record level performance with this board, I really actually love it even for enthusiast builds, because it's got some really awesome integrated RGB lighting zones. It's got a really unique design aesthetic, and I think it's going to make some killer builds for those of you out there interested in building a nice high-end Z270 based gaming system. So let's go ahead and...
I got a question for you actually, JJ, about that board. It's an X-shaped board. It's got these crazy different shape. What was the story behind that? Like, why did that come about?
So that's actually a really good point. You know, ROG for a long time has really had a focus at being innovative in terms of how we approach board design aesthetics. So, you know, we were the first vendor to really shift into having a specialized kind of matte black PCB designs. We had, you know, monochromatic color schemes that we've incorporated. First vendors to be able to incorporate things like specialized shrouds or full cover plates for the motherboard. So when we decided to develop a board like this, the Apex, where we wanted to kind of set the segmentation focus of having a dedicated board for overclocking, taking over the mantle from our Extreme Series board, we wanted to be able to have it have a more distinctive design aesthetic. So you can see that there's an actual cutout shape, an X shape, and of course the new naming convention, this is the Maximus 9 Apex. So that X helps to kind of align with it being an Apex series motherboard. So it doesn't really serve any other function except that it just looks different, it looks distinctive, and it looks cool. But one of the cool things is that definitely as you add kind of some elements of lighting, if you've got like fill lighting, it kind of spills through a little bit on the sides of the boards, which helps to kind of pop out a little bit in builds, which makes it look really interesting.
Oh, sweet. So one of the things that's actually also really interesting about that board is it's got 2 RAM slots, 2 DIMMs. So and there's a 3rd slot.
Yeah.
What's up with that thing?
So traditionally on a regular motherboard, you're going to usually have 4 DIMM slots. Of course, with a Z270 based chipset, it's still standard dual channel, but 4 DIMMs generally now allow you up with high density memory configurations that go up to like 64 gigs. But one of the things that a lot of people don't realize is that as you add higher density memory configurations, especially when you go from 2 DIMMs to 4 DIMMs, it's a lot more stressful on something that's called the memory controller. So that's built inside the CPU, and that actually can limit peak DRAM overclocking potential. So if we take a look at, let's say, like one of our streamlined STRIX series motherboards, maybe the maximum frequency that we validate is like 3,800 megahertz, right? And then we go into ROG, maybe we're talking like 4,000 plus megahertz. But with the Apex board, we really want to get to even kind of the craziest levels of DDR overclocking. So going with 2 DIMMs allows you to have the highest overclocking capability. So take for instance this board, we officially had validation at 4266. So that even allows us to have higher clock speeds in terms of what we can do when it comes to DDR4 overclocking. So really impressive stuff. But where things also get interesting is that when you design a board, like something like here, like on the Apex, a lot of people don't necessarily realize that the more you add into a board can sacrifice and affect your overall overclocking experience, because essentially you're creating more noise, you have a lot of proximity signaling issues, and there's a lot of variability. And as part of these consideration, and when we were designing kind of the layout for this board, we end up having to remove the M.2. But we still wanted to be able to offer M.2 as an enthusiast option, because a lot of enthusiasts love this ultra high speed storage interface. So what could we do? Well, we decided to go ahead and get creative, and we developed an actual DIMM.2 interface. And so what we actually have here is this little guy. This is the DIMM.2. And this installs actually in this slot. But what's cool about it is that you actually have two M.2 slots on it. So you can go ahead and still put two 2280 SSDs on there, M.2 SSDs, have them full in a full RAID 0, still get the highest level of performance. And it also still maintains our focus on airflow optimization. Some of these higher performing SSDs, you can sometimes run into thermal throttling concerns and things along those lines. So us being able to move it to the top location of the board, you get great cross airflow. So in a chassis like this that we have right here, where you've got front intake airflow, that's going to help to stream right across those DIMMs, and it's going to stream right across those M.2 drives, helping to maintain the best performance.
Yeah, and from my knowledge, that's actually not a small problem. A lot of the latest M.2 NVMEs actually have some heating problems, sometimes actually fail. A lot of times because the M.2s the drives are sitting right underneath the graphics cards. These suckers heat up, people are overclocking, people aren't necessarily using the cases the way that they should be with airflow, so that you get actual failure on some of the latest crazy fast NVMe SSDs that are out there. So it seems like it's a pretty cool option. Do you see that a lot, like people actually having issues with SSDs not thinking about the airflow?
Well, I think it's one of these really complicated aspects. When you go about building a system, it's really hard to kind of know exactly how thermals are going to play out. When you go about your environment, sometimes, like take for instance, we're here in Southern California. I'm based out in Northern California. When we get into summers, you can easily sometimes be talking about 100-degree temperature, right? So your ambient can get really, really toasty. You go into other parts of the world where it's not just ambient, but the ambient temperature, but you got increased humidity and moisture and all kinds of different things going on. So having kind of a focus at making sure that you can have a board that's well laid out is something that you really always want to keep in consideration. And it's something that we do on all our boards. If you take a look at, even like our entry-level Z270-A board or higher-end boards, we've tried to make sure that we place the M.2 in a more optimal location so that it's away from target zones like the GPU or for the CPU. Now, if we move to something like this on the mini ITX board, you end up kind of running into still some real world limitations because you've only got so much space that you can put something in. But we did some things that are interesting. With this board, we actually have a large heatsink assembly. So this is the STRIX Z270-I, and for M.2 challenge here, we actually built a heatsink into the PCH. So if we look right down here at the very bottom, the ROG logo, that is a large heatsink. So then we have a large surface thermal interface material that makes contact with that to help to pull away heat from the drive so that we can help to maintain better performance. In addition to that, a lot of times in these situations, either you're going to go with a closed loop water cooling solution, or for mini ITX, maybe a downward firing fan. So that helps to give you additional airflow. And then the really cool part about this type of setup is this board has dual M.2 drives, which is really impressive because that's something you would never think of being able to have in a small form factor rig. So take for instance, I've got two Kingston HyperX PCIe SSDs, one right here on the front and then another one on the back, RAID 0, and then of course I still got additional SATA ports where we've got our Kingston HyperX Savage drives being able to give us a lot of robust storage even though we're dealing with a small form factor system.
That's sweet. Yeah, actually, why don't you give us an intro on the STRIX Z270i board. I know the last generation was really popular. It had U.2 on it, which is one of the few boards, if not the only board that actually had that interface. But this new one's pretty impressive. So yeah, what's up with this guy?
So with this one, actually, this is part of the STRIX series. For some of you guys, you might not necessarily be aware of STRIX series and how it differs from the ROG series of motherboards. So ROG is our highest end line. It's really purpose-built for enthusiasts, for overclockers, for modders, for hardcore gamers. But we've now expanded and introduced our STRIX series of motherboards, which is part of the ROG family, but it's a bit more price aggressive, but it features a lot of the specialized technologies from ROG, but at a more aggressive price point. So this doesn't necessarily replace the previous generation Maximus Impact Series board, which was just an absolutely insane monster mini ITX board, but we definitely wanted to make sure to offer a truly high performance Z270 mini ITX board. So some of the cool things is you've got a front USB 3.1 interface on this. So we can actually go ahead and pull up the page right here for this guy. I can show you some of the little specs that we got going on here. So with this board, you know, one of the main things that we want to try to focus on is giving kind of all the key connections that a user could really look for right now, but also a bit for the future. So when we take a look at the board, you're going to see that you've got a really nice optimal layout. So we've got a high quality VRM design here with dual heat sinks. So that's going to allow us that even whether we're stock or overclocked or more cramped configurations, the VRM is going to operate reliably. Here you can see you've got that large heatsink assembly, which helps to provide that heat conduction for the M.2 drive. You got 4 SATA 6G ports. You have integrated RGB lighting. So we've really been big proponents and really lead the industry right now with our ASUS Aura Sync initiative, which right now we actually got a little bit of a hybrid setup. We've got NCXT's Hue Plus system in there, just because we really love the diffusion and the design of their fans, as well as, of course, their Kraken X62 cooling solution. But right now we have synchronization through our Aura Sync that allows us to go for the motherboard lighting, GPU, the cable mods, RGB LED strips, and then even our Claymore keyboard and our Gladius 2 mouse can all be fully synchronized and controlled. So take, for instance, if I want to switch this over into, let's say, color cycle, I can go ahead and shift those over and you're going to see that. Or I can shift it into rainbow. We've got a lot of different options that are available to us. And at the same time too, if I want to be able to go ahead and make that adjustment to kind of pair it up with something on the NZXT side, I can do that and you can see that. Now there's even a set of DIMMs that are in there that are, of course, from G.SKILL, their latest generation RGB DIMMs, where we're going to be working right now on a forthcoming update that will even allow those to be fully synchronized so that you can really have the most complete level of synchronization for your system. So for, you know, cooling solutions, fans, LED strips, chassis with integrated LED lighting, like this Shogun chassis, it has integrated LED lighting. That could all be controlled through our ASUS Aura interface. But as we move back to the board, there's a lot of really nice things that are built onto this board. So in addition to that, we've got, of course, a full by 16 slot for all you guys that want to run a high performance graphics card. Here we've got a STRIX GTX 1080. You've got front USB 3.0 connectivity and also front USB 3.1. So right now there's not any chassis that are on the market that are using front USB 3.1, but it's nice to be able to know that you can make an investment in a board that's already got that. You know, on the back I/O, you've got USB 3.0, USB 3.1, both Type A and Type C, and Intel NIC, integrated 811 AC Wi-Fi with Bluetooth. So you find that really you're not going to be lacking in any key areas, and definitely from a gaming perspective as well, you've got some awesome audio design. So we've got, you know, our isolated audio design. We've got an operational amplifier on there. We can actually automatically detect your headphone impedance. So I'm a really big audio guy. I know, Josh, you're a big audio guy. One of the cool things a lot of gamers don't necessarily realize is you start to buy sometimes nicer headsets. They need something in terms of higher driving strength. It's called the impedance for the headphone. But the cool thing is that when you plug this in, we've got a little design that essentially can automatically detect the headphone impedance and set the right driving strength so that you get a better experience. It opens up the sound stage, gives you better clarity, and just gives you a better experience. Doesn't matter whether you're, you know, music, movies, or games, whatever it might be.
And that's no joke. I actually have one of these boards or something similar at home, and actually been testing it out. The impedance on like a Sennheiser, any of the HD series, they're going to be like 300 ohms impedance, and it actually makes a big deal. And so, you know, it's one of these things that there's a lot of talk about motherboards, like all these features, that features, but this is one of those features that actually combined with the software, with the hardware, a lot of them have ESS saber DACs. These are actual audiophile components, which personally I think is pretty dang cool. What's nice is the, it used to be the headers on the front audio jacks were the ones that had the nice audio. I think the latest boards is the Z270 Mini. ITX, does that have the back?
Yeah, so this one actually does have dual operational amplifiers, but you're right. Traditionally, like in previous boards, you know, we were really the first vendor to create a full isolated audio design, and we've now seen that embraced all across many motherboard manufacturers. But one of the cool things that we introduced, not only with things like the ESS Saber DACs on many of our RG series motherboards, is also a dual op-amp implementation, so that whether you're using the line level out or you're using the front headphone connection, which is normally going to be on your chassis, you can actually get an improved headphone experience. Where traditionally, in the past, if let's say you had a previous RG series board that, take for instance, had the audio design, you were best leveraging the improvements only through the front headphone connection on the chassis. But we found, interesting enough, a lot of actually gamers were generally still sometimes connecting to their line level output.
Yeah, definitely a lot of people didn't know that. I mean, you look in the marketing and it's like, oh, awesome, you know, integrated amplifiers and all this, and it's only through the front.
Exactly.
Also, I think it just keeps clean. People, especially with some of the design changes that are happening now, want to keep the front looking clean. So plugging everything in the back, showing it off, in different ways, really getting the PC off the ground.
For sure. I mean, aesthetics has been a consistent focus for us. I think you see with both the STRIX Z270i and with the Apex and our entire series of boards, we're really focusing on aesthetics. We've consistently year after year gone to the community and said, what are you interested in? And so if you look at our boards, ROG historically was really known for being kind of a red and black motif. Even actually previous generations, you had red, black, and white for a long period of time. And recently, we've really tried to offer really high quality monochromatic looking schemes. So then that way, regardless of whether you want to do a blue theme build, orange, yellow, black, pink, purple, whatever it might be, I tend to really favor kind of blue, red, black in terms of my kind of color schemes for my type of builds, but having monochromatic color schemes in ROG and STRIX, as well as even on our Prime series, which are whiteboards, really gives the users a lot of flexibility in terms of building your systems. One other point too in terms of the audio design that's pretty cool is this is the first time that we have a brand new audio codec that's being implemented on boards, where historically it's been the Realtek ALC 1150, which was out for a long period of time. It's really kind of like the consistent audio codec that you would see on everything. But this generation, there's a brand new Realtek 1220 codec. And actually with ASUS, we co-worked with them to be able to do some optimization to it. So on ROG versions, there's a very specialized bin version of it that even has higher level of performance. And on all the ASUS models that feature it, we actually have improvement even to the line level input. This is really important for a lot of you guys out there that are streamers and gamers, or if you're using analog microphones, you're gonna get an improvement on the line level in, not just an improvement on the line level output. So some pretty cool stuff that we've done there on the audio side as well.
For sure, for sure. Let's actually talk RGBs. I mean, people are probably tuned into the stream right now, so for anyone who's just tuned in, we've got JJ from ASUS here. I'm Josh from Newegg Studios. And it's one of our first streams in the new space, doing some cool stuff. And that PC that you see there, that's the ASUS Z270 with the STRIX ITX board in an NZXT case.
Yeah, this is the Manta.
The Manta with the new NZXT RGB fans, and the thing is lit up like a rave. So it's pretty crazy. Why don't you actually walk us through what this build was? We actually built it earlier this morning, so we're actually going to be releasing a video on the full build probably next week or the week after, showing actually how to put this full sucker together. But I mean, people have come in here, the thing just looks wild. So yeah, why don't you walk us through what's in that
sure.
thing?
So really the focus was we wanted to build a high performance mini ITX system that didn't really compromise on any key area. So the foundation of this is the overall Manta chassis, which I love it. It's got this kind of curved design aesthetic. This is the red and black edition, which goes perfect with, of course, that monochromatic color scheme for the Z270i board. Helping to keep everything cool, of course, we've got this Kraken X62, so this is NZXT's latest cooling solution. It's a high performance 280 millimeter radiator, closed loop water cooling solution. You've got that beautiful ring mirror design that they've got in there with the RGB lighting. And then from there, of course, you can see the front two fans. These, I replaced the fans that came included in them. The ones that come included are absolutely awesome, but I wanted to be able to add some pop and distinguishing aesthetic elements. So we put air fans here. We then got two more air fans here on the top. So those are 140s, and then a 120 back here. So tons of airflow, a lot of venting here. Really, even though this is a small compact system, a lot going on there. Memory, we've got G.SKILL's RGB Trident Z memory modules, STRIX GTX 1080. So that's pretty much the best you can get in terms of graphics card performance right now. We've got two Kingston HyperX Savage SSDs, 960 gigabytes, two Kingston HyperX Predator M.2 SSDs in a RAID 0, so one on the front and one on the back. You got the beautiful shroud right here, which is a shame because it's covering an absolutely killer power supply, Seasonic's Prime Series 850 watt. The Prime is pretty much, I think, the best of the best when you talk about a PSU that's just been from top to bottom designed for just an amazing level of performance. Titanium class, 80 plus efficiency rating is just insane. And then we added in, just to give us a little bit more touch to everything in terms of the aesthetics, cable mods, RGB LED strips. One we kind of shuffled in right in here, and that's the great things because this is, of course, steel frame chassis. We've got it just magnetic, and then another one right up here at the top. So that pretty much rounds out that build, and it's a pretty beastly system. Even as we were cranking things up in terms of frequency, thanks to that cooler, we're able to get 4.6, 4.7, 4.8, 4.9 plus gigahertz out of this system, and parroting out even on the outside. I love the fact that with the Aura Sync, we can also synchronize our lighting between the Gladius 2 mouse and the Claymore to the Strix Eye as well.
Yeah, and for a lot of people that don't know, when they look at these RGB fans, they don't always have to look like a bag of Skittles if you don't want that look. A lot of it can be actually controlled by either the included software on the motherboard or a outboard controller. In this case, it's the NZXT Hue Plus. But personally, I mean, I think it's all got to move into the motherboard because it just makes sense to have control. So internally, so you see JJ switching it up right now. Just moved it all to red, and it's even the CPU cooler from NZXT. So yeah, why don't you talk about that? I mean, actually, what I'd be interested in is where it's been, but also like where it's going. Like, are there any conversations with some of the case manufacturers to move away from some of their custom solutions towards like an Aura solution?
Yeah, so I mean, this is something that we really pride ourselves on, is that the ASUS Aura Sync initiative has kind of been consistently evolving over the last, really, since we implemented RGB before anybody else onto a motherboard in our RG series of motherboards. So it went from having RGB lighting on our Maximus series boards in the PCH, and then evolving completely more and more to where you got boards like the Formula that had monochromatic color schemes with multiple RGB lighting zones, and then we were the first board vendor to put Aura headers or RGB headers onto a board, to now where we're at. And we're really excited that right now actually every key component that you could ask for can actually fully be synchronized. So we can do motherboard to graphics cards, 2 fans, 2 LED strips with 2 chassis that have LED strips, to even, this BitPhoenix Shogun chassis. It's a brand new chassis that's just right now come out to the market, and this even has new Aura lighting zones for the actual SSDs. So you can get this nice kind of fill lighting, and that's fully synchronized in control, as well as it has integrated lighting displays. So we've really actually tried to do everything, and we're also the only manufacturer right now that can also synchronize the peripherals. So we're in active discussions definitely with all partners, because we want to be able to continue to offer the most seamless level of connectivity and control. But at the same time, whether it's going to be partners like NZXT and others, whether we're talking about, Corsair or we're talking about Thermaltake, we still want to be able to make sure that we're providing, compatibility and interoperability, because at the end of the day, PC DIY is all about choice. So like here, yes, while it's not fully synchronized, and we could have chosen, let's say, like different fans that can offer that synchronization, we really love that diffusion look, right? So at the end of the day, we still want to make sure that regardless of what we're doing, there needs to be, compatibility and interoperability to make sure that everybody can pick what they want.
Yeah, is there any discussion about having some sort of universal standards for everything? I mean, obviously we have the 12 volt RGB headers, although there's now some RGBW headers that are out there, 5-pin.
Well, I think that's part of the reason why when we first implemented, right, we were the first vendor and the largest motherboard manufacturer in the world. When we go about implementing something like our Aura header, we did it with a standardized 50/50 RGB LED strip protocol, right? So in that regard, we weren't trying to make something that was a proprietary specification. This is the same way that we approached developing the front USB 3.1 connection that is on our motherboards, right? We made sure to have it be an open specification that would be supported by chassis partners in the industry, because we want to try to make sure that there's the largest level of adoption that's out there. At the same time, this is always going to be a balancing act in terms of innovation. You guys are extremely vocal as users, and you guys love to come back to us and say, we want to see this, and we want you guys to do this. And when we have to kind of consider those things, sometimes you might have to do it proprietary in terms of the design to be able to reach that as quickly as you can for the consumer. And that's always a challenging act, right? Is what's the right option? But at the end of the day, especially with products like ROG, we're trying to just make sure that we can be as responsive as we can in terms of product designs to give users the benefits that they can look for.
Yeah, no, that's pretty cool. One thing for our audience that's listening, when it comes to the 12 volt RGB LEDs, there's the ones that are made for gaming. They're really nice. They have magnets on them, some better than others.
Yeah.
Those are really cool. But you can also actually buy the ones that, I've got some here that are like the 16 footers. They're just out of a, I think they're made for fill lighting in, say, a kitchen or behind a TV or just any other use. Those actually work. I mean, they're fully compatible. You just have to make sure they're 12 volt. When you plug them in, you got to make sure that the arrows line up correctly. Otherwise, you're going to blow those suckers out. But
you got a lot of different choice. I mean, you can definitely, cost is not a prohibitive option, but even with really high quality solutions, like Cable Mods has a really nice set where they're wide beam LEDs, so they've kind of done a little bit of adjustment to the way that the diodes work to be able to get better dispersion, better fill. But there's tons of different choices that are out there, magnetic, adhesive. I'm a big fan of sometimes chassis that use aluminum, so sometimes you can't use a magnetic, LED strip, so you have to have something. So take, for instance, these are from BitPhoenix. BitPhoenix actually has the adhesion tape, but they're also magnetic, so you actually have the best of both worlds in that regard. So there's definitely tons of different choices, and that's one of really the great things I think about building now in 2017, is that the level of choice you have can sometimes seem daunting, but you can really build a system in any way, shape, or form and really define it to how you want to approach it. Like, there's also a lot of people that sometimes complain about oh, I don't want something to look, so gaudy, or, I don't want it to be so extensive. But to me, I really look at lighting as being more about creating ambience, right? And so I think that for me, this just adds kind of a nice little bit of a distinction to kind of have a cool feel to my system. Once I get all my paneling on, and I'm there just kind of gaming at night, it's just kind of got this cool kind of feel to it. And there are also some cool elements, like in our software, we have elements like a temperature, take for instance, right? So the actual temperature can be shown in real time via lighting. So as your system is maybe heating up, the actual lighting pattern can change. And we're looking for more feedback from the community to maybe that could be sequenced into, let's say, like notifications, right? If you're getting notifications in social media, or maybe game status updates, maybe your life bar meter could be sequenced through lighting. We've got a lot of plans to continue to evolve this, not only just from an aesthetic perspective, but also I think from a functional perspective.
Oh, that's super cool. Can you actually go back to the RGB function for all the fans?
Yeah.
The rainbow effect. One thing that's interesting that's happened just in the last few months, really, and especially at CES, what's happened is the fans have, and just the overall lighting has gone to this diffuse, sort of pastel look, which I think is really cool. You got that G.SKILL Trident Z RGB RAM in there, which just matches up. I mean, NZXT just does gorgeous stuff anyway. But it's a different look than what you've seen in the past, with just bright LEDs just shining right at you. I know that on the STRIX motherboard, the Z270 E, right? It's got that little strip. It's got multiple RGBs in there, but it's a subtler look.
On all of our motherboards, even with boards like we have here with the Apex actually has a huge amount of LED zones. Even though this is an overclocking centric board, if we go over and we take a look at this board, the actual the LED zones are pretty extensive that are built on here, and we are very conscious that when we do present them to a user, we want them to be presented in a way that doesn't seem so direct. So you can see right here, everything is generally kind of hidden under something else, and that's specifically to create more of a kind of an ambient feel. And even actually, we had special new processes developed in terms of how we did the etching and the carving to the PCH assembly, so that we could especially have actually more of a fill light effect. So we don't tend to kind of try to want to have the LED be so directly exposed, because that can tend to be, like you said, really, really bright. So we want to try to maybe angle it so it kind of flows outwards, or have it be underneath maybe the translucent and diffused Q slots that we have on our PCI cards, like we saw in actually our X99 series of motherboards. So I think we're definitely conscientious about trying to make sure that as we add these features in, we want to try to have really a design aesthetic be present that really looks great.
Sweet. And it seems like just the aesthetic overall, not just the motherboards, but also the case design. I mean, who would have thought that tempered glass would have been, the thing that's happened in the last year or so, and just the style of cases as well. I mean, you have skulls and helmets and stuff. Now it feels like we're going into modern design, something that you'd see at like Design Within Reach. Maybe it's a little bit of a stretch, but
well, I think one of the things that we've looked at, and this is even part like initiative. So like here, we're taking a look at our RG certified initiative. So this is something that we worked really closely with a number of different partners to be able to go ahead and offer a lot of choices that really look distinctive and that were different in terms of offering really polished, kind of clean looks that were really complementary with a lot of the design aesthetic for not only the motherboards, but the graphics cards, but any one of the products that we have available.
That's sweet. So actually, let's get into the little case. And we were talking about, we have a new CPU that we dropped in as the i7 7700K, which is the top Intel right now. And I know that there's been some other CPU news from AMD yesterday, so that's kind of all the talk. But what was interesting about this CPU and sort of what you did in that little case was the overclocks. And what I think a lot of people don't know is that there's quite a bit of difference between the actual CPU models that you get. So even though it says, this one's good for 4.4, the actual model that you get isn't necessarily going to clock right out of the box at that, and also its overclocking potential is going to be a little bit different. So actually, why don't you talk about that and sort of what you ended up doing for that?
Yeah, sure. So you're 100% right. So of course, Intel for this generation has had multiple K-series CPUs. So with K-series CPUs, those essentially means though that those are all overclockable. So you've got an i3 that's overclockable, you got an i5 that's overclockable, an i7. And the great thing is that, of course, means that you can get more performance out of it, but the reality is that you've got the silicon lottery. The silicon lottery essentially means that there's no guarantee that you know what the frequency is that you can get out of the CPU. So, ASUS has really had an extraordinarily long track record at providing the best overclocking experiences on motherboards, not only through kind of the classic BIOS or the manual way of overclocking, but also in really developing industry-leading options for automated overclocking. And we want to kind of give you a little bit of a taste of both worlds in this regard. But one of the really cool things that you now have with a lot of the robust features that we've built in is that you can now have CPU-specific overclocking. And this has historically kind of been a challenge because you could have somebody that could build this system right here next to me, and you could build an identical system, and you could have two different overclocking results because the margin between each CPU could be different. Maybe one gets to like 4.6, maybe one gets to 4.4, and then maybe another one gets to 4.8 gigahertz. And for somebody that kind of takes maybe years in between different builds, or is maybe a first-time builder, or is it really just, maybe they're a consistent builder, but they're just not that technically informed on all the subtleties like, adaptive voltages, manual voltages, offsets, cache ratios, memory controllers, and so many other kind of variabilities that you might need to know. It's nice that you can kind of jump into, something like an application to be able to manually tune your system. So what I think I want to show you guys is actually a little bit kind of like what is a real world scenario of how overclocking looks like right now within the operating system environment. And then a little bit, we'll actually show you the more traditional route of manually overclocking inside the UEFI. But let's go ahead and just bring up our AI Suite 3 interface. So this is actually a software application. So when you talk about using a software application, many people think that this is just software overclocking. Technically, this is incorrect because what we're doing here is that actually there are hooks within the software that essentially are talking directly to the firmware within there. So essentially the UEFI, the BIOS within there. So all these adjustments are being made in real time within the operating system on a hardware level. And the great thing is that they're going to be specific to your CPU. So some of the really cool options that we have in terms of how you can define your overclocking is one is all core versus per core. A lot of people don't realize that when you overclock, sometimes you don't necessarily want to get all your cores at one frequency. You might be leaving actually some frequency on the floor. So an example might be maybe my CPU, especially with Kaby Lake, because Kaby Lake is really introducing for a reasonable amount of CPUs out there 5 gigahertz based overclocking. But maybe that 5 gigahertz is best realized for 1 or 2 threads. So maybe 1 or 2 cores, but not all cores. So you want to do maybe per core overclocking because you can get to a higher frequency on 2 cores, and then on all your cores, it'll be a lower frequency. This allows you to really maximize performance, especially in some games or some applications where you get more light threaded versus heavy multi-threading.
What would be some actual examples of that? Like what games in particular for the people that are out there? Like Overwatch, you think?
Yeah, so you find like a lot of like more CPU dependent titles are going to have that. So like take for instance like World of Warcraft had a high amount of dependency on single or lightly threaded based loads. But you jump into some of like the latest generation EA titles, so like a Battlefield, and actually it's pretty well represented across multiple threads, or like Total War Warhammer. That thing absolutely loves threads across the board. So the more threads you have and the higher frequency you have, the better. So being able to kind of balance different things out. Web browsers, take for instance. Web browsers are generally notoriously not really well balanced for multiple threads, so you tend to get better performance from higher clock speeds on 1 or 2 threads. So being able to kind of optimize your system for this regard is something that's really cool. So we give you the ability, hey, just set what do you want to be able to dynamically overclock to. From there, we have a lot of really easy options for the user. So if you don't kind of want to dive into it, you don't have to worry about what's your starting point. But some of the really interesting parts that maybe even manual overclockers actually would have a kind of hard time being able to easily implement every time they overclock would be something like the stress test distribution. What this means is that when we go about applying our stress test in real time, we can dynamically kind of set a balance between how much we're stress testing the CPU as well as how much we're stress testing the memory. And that's important because if, take for instance, I jump into a game, my game might be loading it between like 40 to 60% on my CPU, and I might using maybe like 40 to 60% of my memory. So having a stress test balance in that regard makes a lot of sense. So you could do something like that. In terms of the actual duration, we give you a lot of flexibility to be able to define how long you want to be able to stress test your system. Now, there's no real quote-unquote right length in terms of how long you want to stress test your system. By default, we pick 15 seconds because that allows for a very quick overall auto overclocking experience, and we find in about 80% of situations, it's going to leave you with a stable and reliable final result. But if you really want to eke things out, you want to get the maximum heat load, you really kind of want to test your system, you can go to as much as an hour between each step that you overclock. That's really cool because that means that when it goes from 4.4 to 4.5, it's going to test for a whole hour before it gets to the next increment. So you can feel really confident. So what I tell people for that is like, hey, set it before you go to bed, run the test, and then when you wake up in the morning, it might have run, for 8 hours, right? Depending on whatever the increments are. You also can go ahead and define what's your kind of ratio on how aggressively do you want to target the CPU overclock. Do you want to be kind of normal? Do you want to be more performance, or you want to be really aggressive? That might maybe help to limit the overclock, right? But it helps to really set the target for what's the maximum level you're going for. And even for maybe some users or streamers that are doing like video encoding, YouTube, gameplay edits, stuff like that, we even have an encoding stability option, which is going to be the most stressful and the most aggressive at what you target at limiting your overclock, but it's going to be really specific to your scenario, which is really nice. Another option that's really cool that, once again, manual overclockers might not always think about is AVX instruction sets. If you're doing more professional workflow programs like Adobe Premiere, take for instance, that uses AVX. And that can be a lot more stressful than games. But if you're a gamer and you're never doing anything professionally, there's no reason to limit your overclock by including an AVX instruction set. So we give you the option. It's up to you. Do you want to go for maximum frequency, maximum stability, or kind of trying to find the balance in terms of either one of those scenarios? Last but not least, I think one of the coolest options that we give you is that for people that don't really know a lot about how to approach overclocking in general, we can just give you target points. So one could be, if you're kind of reading the community and you kind of just want to set, I want my CPU to not overclock anything beyond this additional amount of voltage. You can set what that amount of voltage is going to be. So we will only overclock to that voltage limit that you define. Another really nice option is maybe CPU frequency. Maybe you say, okay, I want to go to 4.6 gigahertz. All you have to do is pick 4.6. We don't know if your CPU can do that, but what we'll attempt to do is automatically overclock to that point for you. And then last is going to be actually temperature. I love this as an option. A lot of us sometimes aren't necessarily so much concerned about the frequency, but you care maybe more about temperature. So what you could do is you could pick something like, okay, 80 degrees, take for instance, and we're going to overclock your system up to whatever the maximum frequency is at 80 degrees. These type of things to be able to do manually, or like in the old school way, are really, really complicated. But at the touch of a button, you can do all this.
That's sweet. Sweet. So for anyone who's tuning in right now, yes, we are live. This is not a recording. This is live. It will be a recording later. But feel free to ask us questions. I'm Josh from Newegg. We've got JJ from ASUS here. And for people tuning in, we're looking at Z270 ASUS boards, specifically the Z270i, which is the mini ITX Strix board that's in that little NZXT rainbow bright build right there. And then we also have the Z270 ROG Apex, which is a crazy overclocking board. We're talking about overclocking right now, specifically in the case with the ITX board. And we're getting some crazy, not crazy, but respectable numbers out of i7 7700K. And if you've been hearing a lot of the discussion, it's been about, all right, there's a lot of really complex options to go crazy if you want to really get into your overclock and dig deep and do a lot of flexibility. But what about for the people out there that are just getting into it? And also, I think, I hate to say this, but there's a lot of people out there that buy K-series CPUs, overclockable CPUs, and don't actually overclock. They just stick them in there and they just leave it. So let's talk about the easy options. If you're just getting into this, how easy is it? And also, why, for a newbie question, why aren't they just overclocked already to begin with out of the box?
Yeah, so we're actually showing the easy way here through the auto-tuning software, and we're actually going to leave just pretty much everything at defaults, and I'm going to show you how it would work in terms of what it would be like if I just bought it, installed the software, I click the start button, and see what happens. So let's go ahead and try that here in a moment, but to answer the question in terms of why you don't see kind of a pre-overclock occur is because there's no way for really Intel to be able to know what the CPU frequency is that they could provide to you. When they go and produce the chip, they qualify it for a stock frequency, whatever that stock frequency is, and then the turbo frequency. And then beyond that, they know that there's still additional headroom, but there's no guarantee at what amount of headroom is left and can be reached. It's the same thing like in graphics cards, although in graphics cards there are, of course, vendors like us that we take the time to bin them and then sell you an overclocked edition of the card. So in that regard, there isn't an equivalent in the CPU world, but we've tried to make up for that by offering really great and easy options for people to maximize an overclocking experience. So by opening up the ASUS V3 program, like I said, we've got a lot of different targeted options that the user can do. I'm pretty much going to leave these all at defaults, and I'm just going to go ahead and click the start button, and we're going to see what happens. So this is pretty much right now running in the stock configuration, so the system's going to reboot. Now, I had it set to, I believe, extreme tuning. So extreme tuning means that actually when it reboots, it's going to ahead and apply a base overclock and then start working from that overclock once we actually get into the operating system environment. So all this information is being sent into the motherboard, the firmware, it'll reboot, we'll have our new target kind of frequency, and it'll keep going from there. Now, one of the really cool things is that once you actually complete the entire overclocking process, even if you were to remove the software, the overclock actually stays in place. So once again, while it's software executed, it's happening on quote unquote like kind of that hardware level inside of the UEFI environment. So it is really pretty much the equivalent of you going inside the UEFI, which we'll do a bit later, and we'll kind of show some examples of if I was to manually tune the system and have to dial in every single parameter, and how that can still be really cool. And if you're an enthusiast like me and you know all the different parameters, you can definitely do that, and we'll give you maybe some tips and tricks on how you can go about doing that. But even for somebody like me that's been overclocking for years, it's challenging to be able to say, compared to how quick I could be able to overclock via this fashion and have it be stable and reliable and pretty close to the maximum, it's hard to argue why you wouldn't just go this route, regardless of whether you're an advanced user or a novice user. So you can see that right now, right off the bat, we've rebooted in. We're at 4.6 gigahertz. If I wanted to stop, bam, I could stop. That means I just put together my system. I got 4.6 gigahertz in what, less than a minute? Yeah. Pretty sweet, right? But now if I want to get more, well, I'm just going to click continue. And you can see that we give you a full real-time interface. So you can see now it's jumping up to 4.7 gigahertz. And if I were to open up my task manager right here, I can actually see all these things in real time. So you can actually see the CPUs getting actually fully loaded and fully hit. Now keep in mind, like I said, you can customize the values. You can change how long you want the stress test to be, up to an hour. You can change the ratio between CPU and DRAM testing, so you can have that more stress across the two. You can enable that AVX instruction set, which will be really, really, really hammering the CPU. We give you full real-time values of what's the CPU temperature, what's the voltage that's being applied, and even what's the wattage being applied. Now, one thing that I think is super important as well, though, and that you don't want to forget about, is that our software does something that a lot of times manual users find very challenging. There's literally thousands, close to sometimes tens of thousands of man hours that go into initially setting up our software when we launch it, that takes all the insights that we've learned for that launch of the platform and for that CPU. And the reason why that's important is because there's new types of technologies that Intel develops for the chipset and for the CPU to maybe allow for better efficiency. And the reason why that can be advantageous is our software take, for instance, will allow an adaptive overclock to be in place. This means that once everything's done, if we check our CPU frequency and we check our voltage when the system is not doing anything and it's just idle, it drops down. So that means I get better power efficiency, lower temperatures, and I help to minimize something called voltage degradation. That means that I'm not sending all this voltage to my CPU all the time that can kill it more quickly over time. So that's a really important feature where a lot of manual overclockers, they're going to use what's called a static or a manual voltage, and that means the whole time that my system is always working, it's always getting all this voltage continually, consistently.
Yeah, but of course, no program runs like that. If you're gaming, if you're doing anything, it's never going to be 100% load all the time. So it just doesn't make sense, and you're going to nuke your little CPU pretty quick.
Yeah. So now you can see this is a pretty nice CPU and a pretty nice system. It's pretty impressive. You can see we're actually at just about 5 gigahertz being done automatically, right? So it crashed. Oh, wait, did something go wrong? Actually, no, that's normal. If you were manually overclocking, you're eventually going to get to a point when you're stress testing your system that you reach a hard limit in terms of the wall, either stability or the voltage that's needed, a number of different variables. So that's actually what happened, because this is a real-time automatic overclocking process. So we're tracking all this information. We tracked what was the last stable overclock. This is now being sent back over, being talked between the motherboard, back into the operating system. All that's going to happen in real time so that when we get back in the OS, it's going to roll back to the last stable value. And once we have that last stable value, we are left with our final overclock. So I don't know how long that overall took us, but let's say right now it's going to come up pretty quickly with our final result. But we're going to get maybe somewhere between like 4.8, maybe 4.9 gigahertz in something like less than 10 minutes.
Sounds like a good...
I think that's pretty sweet. And on a mini ITX motherboard, I think even sweeter, right? So that's pretty awesome. And keep in mind, this technology, it is on a wide range of our boards. So you're going to get it on our Prime series motherboards. It's going to be on our STRIX series motherboards and even on our RG series motherboards. But of course, with boards like the Apex, so this type of board, and our dedicated RG boards, they even offer some insanely, really crazy special overclocking controls a special thermal tool that will allow you to do some really interesting things that if you guys are interested in, I could talk about some really crazy ways about approaching overclocking that people aren't familiar with. Sure. So we can see our final result, 4.9 gigahertz. I think that was pretty impressive. Now, maybe I might be able to tweak a little bit more out of this manually, but again, I'm going to have to go in there. I have to know exactly what I'm doing, you know, do it all, stress test, reboot, adjust voltage, maybe make some adjustments, but it's all been taken care of for me.
Yeah, and it was in about 10 minutes. So for anyone who's watching at home, and yes, we are live streaming right from Newegg Studios, it is very safe. Like, this is one of these things that people worry about. They think overclock, they think heat, temps. There's a lot of sort of warning bells that go out. But as you just saw, actually doing overclock is pretty easy, especially with the integrated software. So, you know, if you haven't done it yet and you own a K-series overclockable CPU, you know, just open up that AI suite if you own an ASUS board and hit the button. You know, don't be afraid. The system is also, the motherboards and the software is made to protect your CPU. You can try to nuke it, you will not be able to.
Yeah, I mean, we put a lot of safeguards in there, and I will also say that, you know, of course, quality hardware gets you a quality experience. You know, this really high performance, you know, Kraken X62 cooler, that helping us to make sure that we got a lot of thermal headroom, right? Our really high quality power supplies make sure that we have a high level of reliability and stability as we're pushing the system. So definitely, that's also the other interesting thing is that I've had users that they buy maybe an initial setup and they start off with a basic cooling solution. So maybe you start off with, you know, like the Kraken X51, right? Single 120 millimeter solution. If you run the result right now, and maybe like 8 months later, you save some money, you can upgrade to another cooler. Guess what? If you rerun the results, you can actually get an entirely different result because it's specific to your CPU, your cooling solution. But before I get into the UEFI here, I want to show you what I was talking about. So you can see we have optimized efficiency in place here. CPU is dropping down when I'm not doing anything, but then it ramps up. And same thing, my voltage is staying low when I'm not doing anything. And then as soon as it goes under load, it's going to come up. So let's just go ahead and just show you as an example. I'm just going to run a little bit of a benchmark here. So this is a Cinebench. And we're going to just load it up a little bit here. And you're going to see right there that now it's loaded up and we've gone ahead and increased the CPU voltage. So this is really the most efficient and effective way in terms of being able to go ahead and overclock your system, but it's all done automatically. But for those of you guys, of course, that are, you know, dyed-in-the-wool enthusiasts, I'm sure that you probably want some insights in how we can do it inside the UEFI. So let's reboot into the UEFI and give you guys some, I guess, some pointers there. And if you guys have any questions, you know, feel free and ask. You know, I'd love to hear what you guys have in terms of if you're wondering about specifics on what we've shown, you know, our considerations on maybe building or, you know, overclocking tips. There's a lot of considerations sometimes in how, you know, your DRAM can play into things and how overclocking your CPU and your memory at the same time can limit your overclocking experience. So a lot of little things like that that are interesting.
Sweet.
Love to hear if you guys have questions on that.
There are actually a bunch of questions online, so thank you for everyone for tuning in both on YouTube and Facebook. So some of the questions are, is this a new program for Auto OC or just BIOS?
So this is, so like we talked about again, this is actually a full kind of real-time combined application, right? It's software executed, so you're using it within the operating system environment, but it's working directly in the hardware environment. So all the settings that we went ahead and saw that were applied occurred inside the UEFI. So this is just like if I was manually doing it in the UEFI. There's no difference in this regard, but it's different. If you were to manually overclock your system, you probably wouldn't be using this auto-tuning software. For me, I think this is the way that most users, if they go about getting an ASUS board, should probably approach overclocking, is using our tool. But even some enthusiasts, what I recommend is if you really want to do it all manually and by yourself, just run the baseline. It'll give you a great indicator of what your system is capable of or what your CPU is capable of, right? And then once you're done, you can go in and just manually tune it yourself. But like I said, in most situations, I find you're probably not going to really beat the software because this has literally been, we've been revising the software since the P67 era of CPUs, so since Sandy Bridge. And every generation we've put more time, more effort, more feedback, more options, and we literally have a huge amount of time incorporated in here to be able to offer, I think, a really solid solution.
Yeah. I got a question from Corey on Facebook. Is this autoclock software available for older series of ROG motherboards, or is it only compatible with the latest series?
So that's a great question. So historically, for a long time, ROG did not have the auto-tuning technology. It had many of our other automated features and sets, but This is, depending on your series board, really the Z270 and then our previous Z170 are really were the first boards to incorporate the auto-tuning technology. So if you've got older boards in those generations, there are still some quick overclocking options that we offer. They're called CPU level up. So these are more targeted presets. The main disadvantage, and I can actually show you right here, we still offer some of these presets. So inside the UEFI, if I was to take, for instance, go into like my easy mode interface, we could go and click this little button from like normal into like ASUS optimal, take for instance, or we could go to the easy tuning wizard, and there actually could be some like OC options that you could click on and you could pick different modes, and we would automatically apply a lot of presets. The disadvantage of a preset though is that what essentially our R&D team is doing is they'll take a whole bunch of CPUs, maybe like 100 CPUs, and we'll test them all and we'll find out what's the kind of consistent average of what all the CPUs can reach, and we'll input all those values. And many competitors actually have similar things like this where they have like a button or a knob or different options like this. The disadvantage of when you do something like this though is that if your CPU is either better or below that, the overclock won't be specific to your CPU. So you could put in the preset and when your system reboots, it just crashes because it maybe doesn't meet that preset information. So presets can work, especially if they're dialed in really well. We spend a lot of time on them, but they're not as effective and as advanced as our real-time auto overclocking process.
Sweet. I got another question here. This will be a fun one. I'm building a i7 700K system Z270E with a
So STRIX, yeah, Z270.
Mm-hmm. Yep, the STRIX 1070 custom water loop. Do you think he can hit 5.5 gigahertz?
Ooh, I think 5.5 is probably pushing it. I think realistically, especially with some boards like our Strix series boards, it's got a very good quality VRM design. It's got digital power control and delivery. You can do a lot of optimization. I think maybe you could get to 5.2 on maybe 1 or 2 threads if you've got a great CPU. Keep in mind, great CPU.
That means you got to buy like 4 or 5 CPUs, test them all out, and then
you also have to be careful on DRAM. When you go about your overclocking, make sure that you scale the CPU independently first. So find out what the maximum is that you can get on your CPU before you apply your XMP or you overclock your DDR memory. If you overclock your DDR memory at the same time that you're overclocking your CPU, you could actually be limiting either or. Think about it kind of like if I'm lifting a weight and I lift a barbell, lifting one on one arm, that's got a certain amount of stress, but if I try to do them both simultaneously, I add significantly more stress to my body at the same time. And your CPU has actually different parts of it that operate, one being kind of CPU frequency, another one being DRAM frequency, and there's even another part in there that's the kind of the own core, which is called the cache ratio. And the more you stress all of them, the more complicated it is for your system to run at all those highest speeds. And that's why we try to manage those pieces. But this is actually something cool we didn't talk about, Josh, is water coolers. They also might appreciate something that we offer here on this Apex board, but also on actually a number of our new Z270 gaming motherboards on the RG side, is we have dedicated water cooling zones that are now on the board. So you can do water flow monitoring, which is really cool. You can also do temperature input, or excuse me, temperature inlet and temperature outlet monitoring. So if you get yourself some fittings with temperature monitoring in there, you can actually see what the inlet and the outlet temperature is for your loop, but all built into our monitoring software and on a hardware level. And that's really sweet because the level of water cooling support that we've got on RG boards is crazy. I mean, we've got dedicated high performance water pump headers. So there are going to be like special fan headers that we have on the board that are just for water pumps. That's going to be really nice. All the chassis fan headers have true PWM and DC output control, so if you want to run PWM fans, you can do that.
Yeah, for the people out there, what PWM is and DC is, so if you got those old fans that have 3 pins on them, or 3 wires coming out of them, those are DC. They don't ramp up and down depending on the temps or any other variables. PWM, that means that they fluctuate up and down depending on what you want to have happen, and those are the 4-pin ones.
Yeah.
So it's really cool. I mean, let's talk a little bit about like the fan software. This is one of these things that it's not flashing RGBs, it's not rainbow colors, but it's one of these deals that is actually, in my mind, makes the number of fans that you need, but also just allows you to have a much cleaner and quieter system than the old days.
For sure, 100%. You know, and getting back to that point on the PWM, another really cool and often overlooked feature is the number of kind of cables that you have to consider. So take for instance, here I've got my chassis set up, right? And I've got, maybe in a high performance chassis, 2, maybe even 3 front intake fans. Now, if let's say I have a chassis fan header, so let's just say this was the chassis fan header. If I set this to PWM output and I get just a cheap PWM fan splitter cable, I could run 3 fans and control them with 1 header, but power from the power supply. That minimizes a lot of the cabling that I have to do, but means that I can control and group all 3 of those fans from just 1 header. That's awesome, especially when you talk about like front intake fans or radiator setups. That's really, really cool. But what we can do actually in our UEFI and in our operating system, so I can show you here if we go to like, take for instance our Q-fan control, is we have full calibration and profiling. So when we take for instance, select our fans, we can set, do you want it to be PWM, do you want it to be DC, do you want to be able to customize your fan curve, you can go to manual, and you can even run a calibration option where we'll figure out the minimum and the maximum speeds of your fans. The cool part about this is that if you run the minimum to the maximum speeds of the fans, is that when you click the silent button, the actual fans will turn off, they'll stop spinning. That means that you're consuming less power and you get great acoustics because your system's gonna be whisper quiet. That's really cool. Take for instance, if you're just reading email, checking out Reddit, looking at YouTube videos here on Newegg, whatever it might be, just put your system on silent. No reason to have any of your fans spin, but the moment you jump into a game, right, your fans will spin up accordingly. And you can also do some really cool things that most people don't realize in our latest generation of boards where you have what's called temperature input mapping. So take for instance in a system like this, almost all fans only respond to the CPU temperature. This is actually a pretty coarse way to treat temperature control for fans. What we offer on a lot of the ATX and even our MyTX boards, and even on our mini ITX board here, is going to be different options for how you can have your fans respond to different temperature sources. So take for instance, for Z270, brand new for this generation, you can map your fans to respond to the GPU temperature instead of your CPU.
Is that true for any GPU or just the STRIX?
Actually, for any GPU. Yeah. So the reason why you would want to do that though is that if you measure CPU temperature in a game, so let's say I'm playing like Overwatch, and even at the heaviest gameplay experience, your CPU, especially with the good coolers, probably sitting between 40 to 60 degrees. Your GPU, on the other hand, might be between 65, 75, maybe even 80 plus degrees, depending on the cooler design. Right? So it makes a lot more sense to have, let's say, your front intake fans respond to the GPU temperature instead, so that you get targeted, more direct airflow. But with a board, let's say like the Apex or like our STRIX Z270E or the A, you could have it respond to the VRM temperature, motherboard temperature, optional temp sensor. You can really go about and customize any header you want to be able to have a level of fan control that's absolutely just awesome.
Now, one thing I've been wondering is, so the STRIX, the STRIX graphics cards, they're one of the few cards, maybe the only card that has a PWM fan headers, 2 of them actually on the
Correct.
card.
It's a new innovation.
Yeah, no, it's super cool. I mean, it makes a ton of sense. So, but what is actually going to provide the best performance? Is it actually using the same sensors? Do you want to actually hook up your fan to the front, or do you want to let it be controlled by the motherboard with the temperature?
So that's actually an entirely different alternate option. We'd love, the way that we see it is that if you had either one, it's really up to you in terms of figuring out kind of how you want this design aesthetic. So with the STRIX card, it's a full non-reference card design. You're already getting a super cool, quiet, high quality graphics card. But like you said, the inclusion of these 2 fan headers that we have here on this actual card allow you to connect 2 fans directly to it, and those fans will respond to the GPU temperature. So we developed this as an option because, of course, many of you might not be investing in a brand new Z270 motherboard, but maybe you're upgrading to a new graphics card. So in that way, you kind of can still get this great new feature, but on maybe older generational boards. But I would say, if you're building a brand new Z270 system, then I would probably use the built-in Fan Expert 4 functionality and map it to the graphics card. But the great thing about that is that you're still, even if you put in a STRIX card, not only do you get the ASUS Aura Sync, but then you also get the 2 more fan headers. It's just like you keep getting more things when you kind of add in this experience together by combining the 2 pieces of hardware.
For sure. Personally, I love to keep the cables real clean, so I'd probably go with onto the motherboard, but I've got a separate system that's actually using those headers. Got a question here from YouTube. Looking to build or buy an i5 7600K plus a GTX 1070 system with 16 gigs of RAM. What MOBO should that person get?
So sorry, CPU was, what was the CPU?
The 60, let's take a look again.
7600?
7600K, yep.
Yeah, so you're going with that quad core. That's a great bang for the buck part. So yeah, for anybody kind of going with that class on the CPU, usually my recommendation is the Z270-A. So a lot of people consider that our whiteboard. It's got the auto tuning technology, Fan Expert, it's got, M.2 quality VRM design, isolated audio design. If you want to go for a monochromatic color scheme, so something that looks kind of like our RG series boards, take a look at the STRIX Z270, maybe like the H, the F, or the E, any one of those. If you're going more from the price point that you're talking about, I would probably consider like the H or the F. But those are both awesome boards. They look great, and they're going to pretty much have a lot of the key features that we've talked about, and great OC experience too. So you can definitely make sure to leverage that K part.
Sweet, yeah. For the newbies out there, K means overclockable, so you want to make sure you get a board. And for people that don't know, when you see like Z270, that's the Z in a sense means that that's one of the overclockable boards. So make sure you pair that up.
Correct.
If you have a K at the end of your CPU, make sure you get a Z at the beginning of your motherboard.
Yeah, if you buy like a B series chipset or an H series chipset, we also offer those boards, and you can even get gaming versions of those that have like improved audio, improved networking, some nice designs, but those chipsets won't allow for an overclocking experience. So if you buy like XMP memory, if you buy K series CPUs, you're not going to be able to fully leverage those. So you want to make sure to definitely keep that in mind, because we have sometimes seen people, first time users definitely sometimes make that kind of mistake.
Sweet. Now, why don't we actually walk through, for the new people that are tuning in, we're at Newegg Studios live with JJ from ASUS, and I'm Josh here at Newegg. Let's go. There's been a bunch of questions online about that case there, and like, what's actually in that thing? Because
yeah. So we can do a quick recap. We were going through the UEFI and some OC stuff, but we can recap on what's enabling the OC experience here. So to recap again, what we've got here in the build, this is NZXT's Manta chassis. So it's a mini ITX chassis, a little bit larger, but I love it because it's got tons of airflow flexibility in terms of how you can have your fans set up and the number of fans and the size of the fans. So 140 millimeter fans go in tandem with the Kraken X62 280 millimeter rad. Of course, that's got the nice integrated RGB ring mirror design. You got 240 millimeter fans also here at the top. And if we were to put actually the side panel on, all this features mesh venting, so you get a nice inlet and outlet in terms of the airflow. We've got a back mounted 120 millimeter fan. All the fans on here are NZXT's Air series fans, and those are connected to the Hue Plus that's down here inside, so that gives us RGB control for NZXT's hardware. But we at the heart of the system, of course, have a STRIX Z270-I mini ITX gaming board that has an ASUS Aura RGB header, so that's how we're synchronizing the control here for the graphics card, as well as the Cable Mods RGB LED strip that we have here on the front, on the top, as well as our Claymore keyboard and Gladius mouse. Those all feature RGB synchronization. So if we jump back in this desktop, I can show you how we can switch back and forth between the profiles. We've got G.SKILL's RGB Trident Z series memory. We've got dual M.2 SSDs on this board. That's a unique feature. Only a motherboard on the market right now that has dual M.2, one in the front and one in the back, supporting, of course, NVMe, USB 3.0 support, and USB 3.1 with a front header. Even though there's not any chassis out yet that have 3.1, it's nice to have that kind of future-proof support for the future. And then two Kingston HyperX Savage SSDs, 960 gigs a piece. So I've got a beastly amount of storage, and of course, always at the heart of a high-quality, high-performance system, especially for overclocking here. Earlier, we showed you guys, 4.95 gigahertz is something I can even do manually if I tune in the system. We've got Seasonics Prime Series 850 watt titanium series PSU, fully modular, helps to make sure that we got clean cable routing. So pretty beastly system.
Yeah, no, it's super sweet. One of the questions that came up online is Hue Plus versus the Aura. Will there ever be a time when the twain shall meet?
Yeah, so our perspective is that we're working with actively all partners to be able to enable the ecosystem of compatibility and support for these products. So definitely we're going to continue, NZXT is a fantastic partner for us. They actually have already even released RG certified product that has ASUS Aura Sync initiative. So, definitely we'd love to be able to have it fully seamlessly connected, but, sometimes it's a timing perspective in terms of that. We do even have right now actually RGB fans that have now just been released by Inwin that are fully RGB Sync certified. So if you did want to have right now a full complete system from fans to graphics cards to LED strips to chassis with integrated lighting, like BitPhoenix is a great example of this. They have Aura Sync lighting that's built into the chassis, SSD lighting that's built in. That's all possible through Aura. So right now, we're trying to work with as many partners as possible, and we have options for pretty much every vendor that's out there that produces something that's RGB, with the exception of generally fans, because fans have a main challenge of requiring power as well as control. And so that's why they have kind of been at the very end point of having them linked into the Aura Sync ecosystem. But like I said, with the recent launch of what we're seeing with InWin, that is now also an option as well.
Pretty cool. So yeah, to me, it seems like it's all going motherboard based. All the motherboard software will, in a sense, control all the case and other fan RGBs throughout the thing, because it just makes a lot of sense to have it all synced up through one software rather than these multiple solutions. Plus, you're then using the power of the system, right? You're not relying on a separate external box in the processing of that.
Yeah, no, but I think, you know, at the end of the day too, it's about choice and flexibility. NZXT's built a really nice option with what they did with the Hue Plus. You know, you can connect these multiple fans. They're compatible LED strips, and you can kind of synchronize them all together. And you know, the other reality too is that there is merit to have this type of kind of independent option in the marketplace, because maybe you're rocking, you know, X58, you know, Z97, you know, or you know, X79, different chipsets where you don't have yet RGB headers. Not everybody out there is going to jump into buying the latest and greatest board, you know, of course, every year, right? So sometimes if you want to be able to incorporate some cool stuff like that, having isolated independent solutions works. So I think our perspective is that we see the value in having something from a vendor that offers an independent, inclusive product offering, but we definitely think for future offers, we want to continue to work with partners to try to have it be as inclusive as possible.
That's sweet, yeah, and I can't wait to see more user submitted profiles. So, you know, different ways that the lights light up. I know guys like Corsair have some really great, Razer, those guys on their keyboards, different sort of profiles which look hot.
Yeah, and we've done the same thing with our Claymore keyboard in terms of that, and in terms of innovation, you know, when we get back in the desktop, that's another thing that we've looked at. You know, many of our boards are going to offer specialized 3D printing zones where we have special headers where we offer actually a whole set of files that are available to users that they can print custom cable combs, they can print shrouds, they can print custom main plates, they can do all kinds of specialized designs to whether if they have access to a 3D printer themselves, or if they want to have them printed through a 3D printing hub service, you can get some really awesome, cool, unique our kind of ROG 3D printing accessories to really be able to take your build to the whole next level in terms of a different look and feel.
Sweet. So let's actually talk about a little bit about the price of these fans. How much do those NZXTs run for?
I think these Air fans are like around like the $25 marker, somewhere around there.
Yeah, and that seems to be around where a lot of these new
yeah,
RGB
usually
ring fans
usually when you're looking for like RGB, you know, you can get, you know, very high quality fans that historically usually are, I'd say, between like $18 to about $25. But you can still get very good fans for, I'd say, about like $12 to $14 in that range. You know, you got usually a couple of different options. You got rifle bearing, you have fluid ball bearing. You know, you've got different choices in terms of tonality, look, feel, LEDs. You know, these are some different options. These are BitPhoenix Spectre Pros. Excuse me, not Spectre Pros, these are Extreme LEDs, and these actually have 4 integrated LEDs and they're fixed, and these are different. Now they're not RGB controllable, but I usually find in a build, I tend to fit on one theme. So like if I go back in the OS right now, we had a custom red theme, and you know, you could easily just go with red fans because that's the theme that you know you're gonna fit with. Most users generally in an RGB system aren't gonna maintain a multicolored RGB theme. They're generally gonna pick one fixed color theme, and that's what they wanna go with. So in that regard, if you pick just, you know, red fans, blue fans, green fans, whatever fans you're going to go with, you can reduce the cost and still generally get the same kind of look and aesthetic that you want without having to necessarily pay for additional colors that you're not usually going to use.
Yeah, personally, I've been trying to match my LEDs to the color to the mood I'm in and what time of day it is. You know.
Yeah.
But one of the questions online was, is it worth it for, say, spending so much money on RGB fans? As we all know that the brighter color the RGBs are, the faster your system runs. So it's definitely worth it, right?
Sure. You know, to me, I think the big benefit, so, you know, we were showing some manual stuff. Maybe you can come back to that if people want to know of a manual walkthrough in the overclocking. But let me go quickly here into the operating system. Because really the way that I look at it when we talk about what RGB allows for is it's about having the easiest way to be able to add a distinctive aesthetic to my system. A lot of people sometimes wonder, well, do I really need that? Well, lighting has been something, and I think aesthetics have been a consistent focus. We look at the feedback from year to year when we've pulled you guys in the community, and the number one thing that you guys have consistently kept asking for is specific aesthetic designs. You guys want monochromatic color schemes. You want different types of distinctive aesthetic designs on the heatsink assemblies or in kind of certain patterns, or you want certain lighting features that are kind of built onto the board. And so our perspective when we went about implementing RGB was just about evolving the choice that users had about how they could make their system look and feel. When you take a look at, I think, hardware that we have now it's the best looking motherboard and the best looking graphics cards that have ever been produced. They look clean, they look streamlined, they look really nice, and aligning with the chassis that are now in the market, which are really awesome. There's, you know, a chassis that has about a look and feel that you can find whether you're a minimalistic guy, whether you want to have the kind of like an angle level of visibility, whether you want, you know, a huge amount of volume, you can find that. And so I think that having lighting choice just allows you to kind of a little bit more purposely define that look and feel of your system. So if, take for instance, we jump here into the Aura software, you know, I can easily go and, you know, instead of going from here, I can go back to what my original aesthetic was. And here you can see, of course, we have synchronization, motherboard, VGA, keyboard, mouse, and our LED strip are all in tandem. So when I go now to my red, I've got my full, you know, red synchronization right there. And then to round out, of course, the NZXT piece, I can open up the CAM software. I'll head over to Hue and go in my settings and fix that. And now I've got all that in red. And that G.SKILL memory would also even be set to red as well. This is the latest generation kit that just released, and so we're waiting right now for a new update. We'll have it out in the very short future, but you'll even have full memory integration, so you could go 100% you know, red across the board and just have it look really distinctive, really cool. And you'll actually see even in a build, the build video, we actually were featuring some really awesome DIMMs. These guys right here from Avexer. Their Impact series. So these are actually RG certified DIMMs. They feature a really cool kind of a low profile, really nice kind of LED pattern finish that's all in red that just gives the board just even a kind of more aggressive look and feel.
It looks sweet. So one of the conversations going on right now on our Facebook channel, people are going back and forth. Is overclocking worth it? Specifically, if you're gaming, you know, do you really need to overclock? How much actual real world FPS are you going to get?
You know, it really depends on your games. I mean, can you get an actual legitimate performance improvement? Yes, you can get a genuine performance improvement from overclocking. Now, definitely, does that mean that you have to overclock to be able to get a great gaming experience? No, you could definitely buy, you know, a non-overclocked, you know, i5 and be able to handle a lot of games without any issues. Now, if you're looking to be able to get the highest level of performance, especially for users that are going to higher resolutions, whether you're talking about 4K, 2560 by 1440, you're going into ultra high refresh rate. You know, we just released the new PG258Q. That's a 240 hertz monitor. Being able to get a game to be able to run at that level, you need every single part running kind of at its highest level of performance to be able to get that type of frame rate.
What kind of games, what kind of people are actually running at that kind of
definitely, I mean, for a monitor like that, that's all about first-person shooters. So you're talking about, you know, stuff, well, first-person shooters and I'd say competitive shooters online. So, you know, Team Fortress 2, Counter-Strike Go, you know, Arma, Battlefield 1, Overwatch, you know, any kind of game where, you know, it's about kind of competitive shooting kind of dynamics, that's definitely a monitor that's going to be squarely aimed at that type of audience. But the numbers that we see really depend on the game engine, so it's hard. In some games, you might see a couple of frames, but in another game, you could see sometimes a 10 FPS swing. But there's no way to conclusively know that. It's really kind of per game engine, and depending on also the resolution and the settings that you place. Some games are more CPU bound, and so there are more GPU bound. But whether you can receive an actual benefit, you can definitely receive a benefit. And I would say, also, if you've made the investment in K-series hardware, why not take advantage of it, right? Why not get that extra level of performance to be able to get you a little bit more? And also keep in mind that it's not just about max frame rate. If you can improve even aspects of your minimum frame rate and improve frame latency performance, that's actually can even be more important because that's the minimum kind of lowest common denominator of the way that your system is performing.
Sweet. So let's talk about actually like what you can actually see. There's a lot of comments online, usually from people who own these like boxes that go near a TV or something about human eye only sees 30 frames.
Oh yeah, so that's definitely wrong. I mean, I challenge anybody that has ever genuinely used a 120 hertz monitor going from a 60 hertz monitor, just actually scrolling the desktop, right? Yep. The refresh rate improvement, being able to double click and open up boxes and have it be that much more responsive, it's a night and day difference. So while definitely I think gaming is most directly beneficial in terms of high refresh rate. I like high refresh rate even just on my a standard desktop. When I'm opening up a lot of tabs in my browser, if I'm moving a lot of windows back and forth, just the fluidity and the improvement that I get is so nice. So that's why ultimately my daily driver monitor, right, is It has a G-Sync, it's got IPS-based display, and it's high refresh rate because I wanted kind of everything. I wanted good picture quality, I wanted high refresh rate, and that's one of the great things that we have with a lot of our gaming monitors. Choice is up to you. Do you want ultra high refresh rate? Do you want high refresh rate? Do you want adaptive synchronization technologies? Do you want IPS? Do you want curve-based panels? At the end of the day, there's a lot of choices, but it comes down to what is it that you want based on your usage scenario, your gaming experience, and things along those lines.
Sweet. Let's take some more questions from the community.
Sure. I'm going to try to get to 5 gigahertz while you guys do that.
Let's try to get there. Yeah, for anyone who's tuning in, we're live streaming from Newegg Studios with JJ from ASUS, this guy knows his stuff. So ask your questions. I'm Josh from Newegg, and we are trying to get some overclocks on this thing. For people who are tuning in, the nice thing about overclocking is don't be afraid. If you got a K-series CPU, go into that AI suite, hit that button, and do an overclock. A lot of people don't do that actually. It's kind of sad, but
especially if you got an ASUS board. This is one cool option here too for you guys that are overclocking. We can show you, I guess, if you guys really are interested. But there's a really cool option that we have here that's called an AVX instruction set offset. What this means is that if, let's say, we have our system set to 5 gigahertz, but that might not be stable under the most stressful type of AVX applications, that's not going to be representative of normal games or normal general applications. But we have the ability that we could apply, let's say, a reduction to the actual ratio by 2. So that means that then the moment that AVX instruction set kicks on, it's going to drop down to 4.8 gigahertz, helping us to make sure that we maintain a high level of stability. These are kind of the awesome options that you have available to you on ASUS UEFI boards. And as you move into our higher end boards, we even have special tools that are called our ASUS thermal control tool, where you can actually set your overclocks to be based on actually temperature properties. So that means that once you actually have certain temperature loads that are present, you can have higher overclocks enabled, and then when you get to higher loads that produce higher temperatures, you can actually go to lower overclocks. This really allows for a targeted level of really maximizing every ounce of overclocking that a K-series part, when paired with a board like the Apex, the Maximus Hero, the Formula, any one of those boards to really be able to give you really the best experience possible.
That's sweet. Got a quick question here. Any plans to implement 10G on more motherboards?
On more motherboards, well, we were the first vendor to really implement 10G on boards, and we still continue to offer those options. We have them on our workstation line as well as on our gaming line, but it's something that you're going to see rolled out on a slower cadence. The cost right now on a 10G controller is quite expensive for us to implement, so because the majority of users don't really have an immediate need for 10G, it's going to be coming down over time and really focus first and foremost on our highest end SKUs, I would say in our WS line for content creation professionals, where they have a demand for kind of high network load configurations, and then also for the highest end gamers, we'll still probably look to consider implementing it. There's also one other consideration, is that driver optimization for some of the 10G controllers aren't necessarily super tuned yet for like gaming and general workloads. So that's also something that we have to work with closely with the chipset developer that makes the 10G controllers, so that we make sure that we can give you guys a great experience regardless of what you do on that network card.
Sweet. And off of that question, same person, what about an ITX WS series motherboard?
That's a good one. So, we get a lot of questions like that over time in terms of users, do they want an option like that? So while we've seen a huge amount of interest in many ITX, and you can see that we're bringing it to the table with awesome boards like what we got here, developing WS boards, they have quite an extensive level of validation and interoperability testing that we have to do compared to our normal boards because of the demands that we place once we call it a workstation series product. And right now we find that generally most enthusiasts in that space or content creation professionals, they aren't necessarily immediately asking us for ultra small. They still care most about kind of expansion and connectivity, right? So they want to be able to have a large amount of storage. They want to be able to have like multiple HDMI capture cards, so 10 ports, maybe a multi-channel RAID controller. Maybe they need to be able to have, an SDI interlock card to be able to go out to an outboard solution, specialized audio cards. So in that regard, like micro ATX and ATX tend to work best for that segmentation of the market. But does it mean that we won't ever do it? I'd say no. I think it just comes down to how many people continue to ask for that type of solution.
Yeah, so user out there, just keep asking for more ITX WS series boards. Got a few more questions online. Someone has asked multiple times, are the Thermaltake Ring Premium Plus RGB fans worth it, worth the money for like 100 pounds versus obviously on our friendly island?
From our friends across the pond.
Yep.
You know, that's a really good question. I haven't had the opportunity to test the latest generation of Thermaltake's ring fans, but I did try their first generation, and I really loved their design. The overall kind of spherical design, which is somewhat similar to what you see here within the hue-based design, I think have a really cool aesthetic to it. They use some nice high quality bearings. They also do molding around there to be able to absorb vibration on the actual frame for the chassis. So I think they're really nice fans to be able to use in a build. You know, as far as ultimately whether you feel that it's worth the investment compared to other offerings, that's kind of where you got to look at the marketplace in terms of what you think makes sense for your build. But my experience has been quite nice with them.
Yeah, so the answer, so roughly they're worth it in terms of quality and performance, and I know the latest ones actually are able to do, similar to the NZXT ones that were here, they're able to offer that full-on RGB rainbow effect all at once. The original boxes for the Thermaltakes ring fans, it had that sort of rainbow effect, but you weren't actually able to get it in real life. It was one color at any given time.
Yeah, and so by the way, while you were just taking the question, you know, I just was in the UEFI and I just got to 5 gigahertz on, you know, a mini ITX motherboard, so I think that's pretty cool.
I'll give you some applause right here.
Thank you. I got a soft clap, soft clap, soft clap. All right.
Don't want to blow out the mics.
I think that's, you know, that's pretty impressive considering that historically, you know, a couple of years ago, when you look at a mini ITX board, people really looked at it being a more limited platform. So when you consider that you can reach almost probably one of the realistic limits of what we would see in a traditional enthusiast CPU frequency, but in a small form factor system like this on a small form factor board, it's pretty impressive. But you know, at the opposite end of the spectrum, you know, the cool thing about it is that, you know, going to a board like an Apex with even a higher quality board design and even more specialized tools, you know, who knows, maybe we could get even just that much more out of it. So it's cool to be able to offer a wide range of options for users to really be able to take their K-series CPUs to a whole nother level in terms of performance.
Yeah, what's nice is, I mean, people are at home who are tuning the stream, are looking at that case, and it looks super nice, especially when we have like the RGBs going and everything. But it's all parts that are off the shelf. This isn't some custom crazy system. You know, you've got, what is it, a 240 millimeter?
Yeah, I mean, everything right here you can get, you know, today on Newegg. You know, you could order every single one of these parts.
Newegg.com. What do you think the total cost is?
You know, that's a good question.
If you take out all the ring fans.
You know, it's a little bit tricky because probably for a normal user, I wouldn't have gone so heavy on recommending, you know, the level of storage that I have. You know, 960 gigabyte SSDs aren't necessarily cheap. I personally will say, for me, I saved my money for my build. Actually, while I have 2 4 terabyte drives, which are primary RAID 1, not RAID 0, but RAID 1, mirrored general backup volumes, my primary operating system and game storage, and then secondary local access storage is all pure SSD. I spent the money on it because I wanted to always have just an absolutely buttery experience, regardless of what I was doing and where I was pulling my files. So I am a fan of it, even if it takes more time. But I would probably ballpark, if we had to put all of this together, I don't know, like 1750, something like that.
Yeah,
probably.
that's with a GTX 1080 STRIX
yeah,
OC
yeah.
on there.
You know, but you know, you could build a very similar system. You know, you could remove, you know, these air fans, and you could go with, you know, keep in mind the Manta already comes with fans, right? This Kraken X62 comes with great fans right off the bat. You don't need to necessarily put these in. Right now, if I were to put on the front panel, let's see if I can get this on here. Oh, can I get it on? Might be able to get it on if I can get it on there. But anyways, you know, you don't really notice, right, if you were putting those fans necessarily in there, right? So you're not necessarily losing them out. You get a little bit of a nice backfill to it, but you know, keep in mind that you don't have to add in cost to replace these fans. It comes also with a back mounted fan. You just don't get top fans, right? You know, same thing. PSU wise, this Prime titanium PSU, absolutely beastly, and I think for the money, it's a great PSU. But for most users, I tell anybody buying a system, 550 watt to 650 watt for 90% of builds is 100% okay. You don't need 850 watt, 1000 watt, unless you're really aggressively overclocking, maybe going into multi-GPU configurations. So you could save money there. Of course, one M.2, you don't necessarily need 2 M.2 drives, which I have. You know, I would probably say, you know, go for a nice 240 gig primary operating system SSD, 1 terabyte, maybe 2 terabyte mechanical drive, which you could slot in right there. You know, same thing, you don't necessarily need to go on RGB. You could get yourself some nice Standard DDR3 DIMMs, 2400, 2800 is really the sweet spot in terms of price to performance to density. So you could really easily build a system that looks very similar, even still keeping something like the RGB LEDs. I mean, these cable mod LED strips are only 20 bucks a piece. So it's not like they're expensive. You could still have a really cool looking system for a much lower price, But here, I think what we just wanted to show is kind of a cool example of, if you spend a little bit of time, you kind of threw a lot of different options, what are some of the different experiences you can put? And that's I think, the awesome thing about PC DIY, right? I think that's why any of us that are enthusiasts, whether it's your first build or it's your 100th build, depending on how many you build, or for me, I don't even know how many builds I've built at this point.
About 100 since you've been here since Monday, right?
Since Monday, yeah. We've put quite a number together, so make sure to subscribe to YouTube here at the Newegg Insider channel, man.
Yeah, no joke. We've actually been filming a lot of cool stuff that we actually can't talk about yet because there's been some stuff that you maybe have heard about. But yeah, definitely subscribe and come back again when we've got some more stuff. JJ will actually be coming back next Thursday because there's some cool stuff happening then. I do have one question.
Look at that, from 5 gigahertz Cinebench going. I like it.
Nice. Now, if you put the actual cover on, how stable do you think that's going to be?
I don't know. I mean, that was a quick just number kind of I punched in there, so it would still probably need a little bit more fine tuning to get in there. But if you talk about putting into the side panel and everything like that, we've got a little bit of a delta in there in temperature. I might need to maybe put up a little bit more voltage in there just to be able to kind of get it fully stable. But when we were running our stability test, actually it looks like we might have got a lock, so I need maybe a little bit more vid in there. I'd probably say we're in the ballpark of, especially with this Kraken X62, under normal workloads for gaming, I think you're going to be generally in that 70 to 80 degree sweet spot of where we want to be on total load temperature.
Yeah, and for people out there, that's pretty nice. That's pretty nice, especially if you're gaming or pretty much doing anything. Now, what about, got a question here for a 40-inch G-Sync. Is there anything coming from ASUS?
40-inch G-Sync. Well, as you know, the biggest right now that we produce is our ultra-wide G-Sync monitor. Getting panels is quite difficult in ultralight charges because you guys also have a lot of heavy requirements when it comes to things like you want really great response times, you want G-Sync,
they want it all.
Refresh rate, and that can be very complicated, especially when we have to go through a lot of validation. So right now, I think we're starting to enter into offering you guys a little bit more options, not only in terms of curve, but bigger panels, whether you're talking about, 32, even 34-inch base offers. But as far as whether there's something 40, we've had some discussions internally, but I think as of right now, I think we're going to continue to want to probably target where the mass majority of users are interested in, so that 24 to, probably about 34-inch range in terms of monitors.
Sweet. Now, for people looking at this case, this is an ITX build with the STRIX Z270 motherboard, which is a teeny little motherboard. Interesting, the Manta case from NZXT is not that small. It's fairly similar to the NZXT S340 case, which will take full-size ATX motherboards and just give you some more room to play around in there. But I think the Manta gives you some additional breathing room. It's not like one of these super teeny tiny ITX cases.
Yeah, well,
thermals.
And the other part too is that you could definitely go to much smaller chassis and still fit in quite a bit. There's some really impressive chassis that are now in the market that volumetrically allow you to stuff a huge amount in there, even with high performance closed loop water cooling solutions in a very small liter package. But one of the things that I'm still looking for here is a visual aesthetic. This gives me a certain amount of real estate to kind of tell a certain look and feel that I want for my system, right? I get a certain amount of fill light, I get a certain amount of kind of flow, I get a certain amount of look at being able to kind of see, here's my motherboard, here's my memory, here's my storage. And so as you kind of compict things down, they tend to kind of stack them on one side of the chassis and then on the other side of the chassis to volumetrically maximize space. And that's great because you can have some really killer stuff in terms of a system that's really thin in that regard and still packing a lot of hardware, but it's not going to be that same design aesthetic. And definitely here, once I throw on my side panel, my front, I've got something that looks distinctive. So again, choice on the size and the shape and, the volume. Although I'd definitely say, having something a little bit larger on a smaller form factor build is always nice because it's a little bit easier to work in. Yeah. Yeah,
no, for sure. That's absolutely the case. The little itty bitty cases, especially if you're using cables, it's some of the trickier builds to do. But also, I mean, with the new CPUs and also the new graphics cards, they're running at much lower temperatures than just the heat monsters of days past. So you can have a little teeny tower like from like a Silverstone Milo ML08 case that is going to have just really good performance. One of the questions on YouTube right now is, will this system be able to run high settings on games? Yes, it'll be able to run ultra pretty much everything.
Yeah, this is pretty much, short of adding in a second GPU, right now that it's overclocked at 5 gigahertz, even if it was at stock, right, or we take it down to 4.8 or, whatever, 4.6 gigahertz, GTX 1080, high performance, DDR4, it's pretty much you're going to play anything else. And then you add in, right here, we've got a PG278Q, so G-Sync monitor. So you've got an adaptive refresh rate for the GPU to that. That means we don't really have to worry about this whole target frame rate, consideration. It's going to be synchronized, so we're going to get fast, fluid, and responsive gameplay. So yeah, just about anything you want. Yeah, and you can see I made a slight adjustment. Bam, there we finished, at the 5 gigahertz marker there.
It's pretty sweet. So in real world performance, my guess is you're probably going to see at least 130 frames on something like Overwatch on epic settings, probably on that monitor.
Oh yeah, you're just going to get monster performance. Pretty much very few scenarios you would find that you probably would be limited in performance. And keep in mind that we still got a lot of airflow because of the chassis consideration we have with a lot of the airflow that we've got here from the fans in the front. That we still got overclocking headroom with our GPU. So I'm just overclocking right now the CPU, but I haven't even gotten into overclocking the GPU.
And that's above and beyond what's the natural overclock that comes.
Exactly. Already with the STRIX card, you're going to get an out-of-box overclock. And our cooling solution, we aggressively do what's called GPU boost-based overclocking. So the card will automatically overclock because it's already cooler. But we could even take that even further, So we could even be getting an extra, maybe another, on average, I'd say GTX 1080 overclock, another probably like 6 to 11 frames. Out of overclocking the GPU on just about an average across a lot of stuff. So that's a lot. You add in then the performance we're adding in from the CPU overclock, it's pretty beastly.
It's pretty good. And what a lot of people don't realize, especially with the latest generation motherboards, the thermal cooling, the fans that ramp up depending on temps, is how silent these systems are. Like that STRIX card with the triple fans, it stays really quiet. You may get one fan spinning, you may get two, but it's not going to just be screaming all the time, which is one of those considerations people don't think about. They're thinking about only performance, but they're not thinking about, okay, do I actually want to have a monster case in huge performance sitting right next to me? No, it's actually, you can live with this case on your desk, or one of these systems these days on your desk.
Yeah, and that's something that definitely, that's 100% true. That's the beauty of now having, great choices in micro ATX, mini ATX, and even ATX. And so just for here, I don't know how it's going to run. I'm just running it. One of the really cool things that we also offer the community is our full ROG Real Bench Stress Test Full System Suite. So this is a free utility. It was developed with the community in mind, where we take a lot of real world applications, so full image editing, hand bake, transcoding, OpenCL, heavy multitasking. We have 2 different modes, a benchmark mode and a stress test mode, so that when you go about overclocking, you can run full stress tests and benchmark results at stock. Make sure your system's stable at stock first, and then also create a full baseline when your system is at stock, and then rerun it when it's overclocked, running not only the stress test, but also running the benchmark to see actually how much of an improvement you got. So that's really cool. Not only are we giving you great options in the UEFI to manually overclock, but also you have, of course, a great set of options in terms of the auto tuning, but we're also giving you ways to measure that so you can clearly see that you've increased the performance. You can saw, we just hammered through that image editing benchmark. It just ran through, I think it took like about 20 seconds or something like that.
Yeah, and we're not burning up in here. It's not screaming loud. It's it's pretty nice, like as a build goes. So
yeah, our temperatures right now. CPU hasn't been doing much, but if we rerun to see what we look like here, if I rerun this Cinebench, so I put a pretty heavy load on there. You can see, it's pretty nice temperatures considering right now. 5 gigahertz, and then with that load, you can see you're floating, between mid 70s or so. If under sustained, probably long-term load, you'd stay in that regard, because keep in mind, games are never going to equal the same type of load that you're even going to get from Cinebench with 100% consistent loads. If I was to open up Unigine, which would be a pretty good representation of a game engine, that CPU load frequency is going to be 40 to 60%, and the temperature actually for the CPU is even going to be lower.
Sweet. Well, this has been a lot of fun. Thank you for coming here, JJ. For people who are tuning in, we've been testing out the ASUS Z270i motherboard. That's a mini ITX board. It's a itty-bitty one, and just doing some overclock. So we hit on an i7 7700K CPU. We hit 5.0. I say we, it was JJ with his skills. But a lot of it, we got to 4.9 just on the auto overclock feature. So if you're out there, you've got a K-series CPU, make sure you open up your AI suite. It's one click, hit another click, or double click, and you're gonna then overclock, and the system is gonna do it nice and easy. And you don't have to worry if you're afraid you're gonna burn your sucker up. That's almost impossible unless you just throw some cooking oil into your PC.
Yeah, it's quite hard. We've tried to make it as easy as possible, and for those of you guys that really want to go about doing it, the manual way as well, we did show some kind of insights in there. I didn't go into some of the specifics about understanding, manual and adaptive and offset voltages, but I would strongly recommend you guys can check out an awesome resource that we have. It's called EdgeUp. It's edgeup.asus.com. We have a full KB Lake overclocking guide written by one of my partners and absolutely brilliant guy when it comes to overclocking. His name is Raja, and it's got a lot of depth to it to help you kind of understand all the great tools that we enable for our Z270 series of motherboards on how to be able to manually tune and overclock and do a lot of really cool stuff, especially with our our ASUS thermal control utility, which allows you to do targeted overclocking based on temperature, which is a kind of crazy scenario, but it really allows you to eke out even more performance. And you can also find out more information on boards like not only the Strix-I, but even the Apex, which we touched on, but is an amazing board as well. And I definitely would recommend you guys check out the product page for it, because once you get to see this board fully lit up, it's quite impressive.
Yeah, and I mean, maybe we're a little aggressive thinking that we're going to be able to benchmark everything in one stream, but next time we'll have to come back to the Apex, because that thing is very, very cool, and I can't wait to see what that thing does. But for people who are at home, be sure to subscribe to our channels. If you're on Facebook, go to subscribe to our YouTube channel, because we're going to be doing a lot more of these streams. But also, we actually filmed earlier in the day a video with JJ building that NZXT killer mini system right there. That's going to actually land in a few, maybe next week. Maybe next week we'll have it up live. So if you actually want to see a step-by-step about how to build this PC, but also like what is the logic that goes into it, and actually how easy it is. It is Legos for adults, so you should definitely check it out. Visit Newegg.com to buy all the parts, and keep checking back. We've got some really cool stuff coming up, especially next Thursday. Kind of a secret. You may be able to guess what it is, but JJ will be back then, along with a friend of his from ASUS, to do some really cool builds and some exciting overclocking demos. So overall, I think we're ready to sign out, and thank you everyone for watching and tuning in to Newegg Studios live streaming.
Yeah, thank you guys so much. If you guys have any questions or comments, follow up on stuff that you've seen here on the stream that's related to ASUS, feel free to go ahead and drop them into the comment section. I'll do my best to go ahead and get you guys back when I can. And with that, thanks guys for watching. Appreciate it.
Sweet.